welcome to CS 527 lecture number 7. So today we'll start a relatively easy sub chapter, which is chapter 10, that is system level input output. So most of the concept that we'll discuss here, the basics of this concept is already known, or you can say that all this concept we have already used in some upper level. So we'll go little bit low level and try to understand the internal system level things of input outputs. And what we will do today, we'll try to complete this chapter 10 today. So maybe the number of lectures will be long, and if it is taking too much time, then what I will do, I'll divide this lecture into multiple files and then I will upload it. But my aim will be completing this complete chapter today. Okay. So most of the thing what I will do here, I'll explain from book. Why? Because there is I'm not writing program here live. Why? Because most of the things are very simple and you'll understand it if I explain it some already written code. So I'll run some code which are already written, and I'll rarely write live programs today because it is not required, because the concept that I'll discuss are simple, not like the concept that we have discussed in chapter 8, because most of the concept in chapter 8 were new, but here it's not like this. Okay, so starting with the input output. So if I go start with input output, then if you say what is called a file in Unix. So Unix file is a sequence of m bytes. Means if there is a file stored in Unix system, then it's a sequence of byte b0, b1, bk to bm minus 1, right? So that is nothing extraordinary here. We know that a file is a sequence of bytes. So then if we want to perform some operation in a file, then it means that we have to, first thing it's important is opening a file. How to open a file, all these things we know from C programming, file handling, but this is a little bit low level thing that I'm discussing here. So every time what we will do, what if we open a file, so for example that maybe from C programming or anywhere, if we open a file, then internally what kernel will do, kernel will open the file for you. It will create some internal data structure for that particular process to handle this file. For example, process 1 wants to open a file that is called file1.c. Then what kernel will do, kernel will open that file for that process, and it will maintain some internal data structure for to do perform a read write on that file. And what it will do, it will only return a number to the process, that is called file descriptor. So and all the communication to all the read write or all the access to that file will only perform through that file descriptor that will be shared by the kernel. So that way I will discuss in more detail today. So it means that whenever we open a file to read or write or anything, then kernel will handle everything. Then and only thing, kernel will just return a file descriptor. It's an integer number to us or to the process. Okay, and everything that we need to do, if we want to write something, we to read something, we just need to pass this file descriptor, and then remaining things will be handled by the kernel. Okay, so you have to remember two things, that there are three file descriptor already there in for every process. This called 0, 1, and 2. First file descriptor is for standard input, and second is for standard output, and third is for standard error. So they are called like this, and it is defined in this header file as unistd.h. It is std in file now file number, std out file number, and std error file number. So you know already all this thing. Means standard input means whenever we, this is a terminal only, whenever we go for some scanf or something, then we give input from the standard input, that is through which we can enter from keyboard. Standard output is again the terminal from where you are printing using printf function in C. Okay, and then standard standard error is also it will also print error in terminal. Okay, so these are the three file descriptor already there. So if you want to open a file, suppose if you want to open a file now, so the file descriptor that will give is at least greater than 2, because otherwise 0, 1, 2 are filled with these predefined files, file descriptor, input, output, and error. Okay, So remaining things I'll discuss one by one here. And as we know that if we are reading a file, then at the last at the end of the file, it will create a event called end of file. That that results that it means that the we have reached the end of this file. Closing a file is important because when we close a file, then as I said that all the data structure that created by a kernel to manage this file will be removed from the kernel. So that's why closing a file is very important. So now opening and closing a file, so that we'll discuss now here. So before going to this function, let us go to our old style that we know from our btech level, is how to open a file. So if suppose if I go here, if I let me open this code. So if you see this code here, this is a simple code, right? What it is doing, it is opening some file pointer. We are going for a file pointer, then you are opening a file, f open my file and read mode. And then if file pointer is null, that means fade to open. And if everything is fine, it will go here. And what it will do, what it is doing, f get us. What f get us do, f get us read one line at a time from the file. So it will read one line at a time from this file. Okay, and it is printing it. So if I run this code here, gcc f open, I think example 2, I'm sorry, okay, if I run this code, see it is reading all this line from this file, myfile.txt. There is a file here called myfile.txt. If we open this file, see these are written in this file. So one by one it is printing all this thing. Okay, so this is clear, right? So we know it. So this f open function we are using in C, we know it from our btech level. But what we will do today, this f open function is not a system call. Is f of n function is it's a higher level function. So inside this f of n function, there is a system call which is calling, which is creating, which is interacting with the kernel, creating the file descriptor and all. But if you see in what you can say in C programming, there is no specific file descriptor returning. There is a file pointer returning, right? So we'll go to even low level and try to understand it from here. You can see the system call that is used to open a file is this, and it is defined in this header file. So see the function call is integer open character. This is the file name the which you want to open. These are the two flags. This is the flag and this is mode that I will explain. Flag you already know. Flag means here there are three modes: or read only, or write only, and read write. So either if you go for this, then it will go open this file in read only mode. If you go for second one, it will open the file in write only mode. And if you go for third one, it will open the file for read and write. There are other options also possible. The other options are written here, that create means if you are trying to open a file and the file is not there, then an empty file will be created. So that create can be used with both read and write. Means if you want to open a file in read only mode but file is not there, then if you are also opening with in combination with create, then a file will be created. Okay, then similarly there are two other options are there. Truncate, if file is already exists, then it will truncate it and it will create a new one. Append means if there is already a file there, if you want to write something, it will write at the end of this file, means original content will not be deleted. So all this thing I think you already know from the C programming. Okay, so and mode I'll explain just after a few minutes. So before that, let me explain what it will return. So one thing you have to remember here, whenever you will read this book, you will find a lot of function prototype, or you can say function declaration. So every time what is important is you have to remember what each function returns, because these will be used in other programs or other examples also. Mostly all the function that is written here in this chapter will be used in next chapter when we will discuss network programming. So you have to understand the purpose of each of this function, and also you have to remember the return, what values it returns. So for example, here it will return the new file descriptor if everything is okay, and if there is some error, then it will return -1. So -1 means there is an error, and if there is no error, it is return, then it will return a positive number. Positive number means the file descriptor. Okay, and descriptor should be at least greater than 2, because 0, 1, 2 are reserved. That I have already explained, right? So return is fine, then we'll go to mode. So before going to mode, let me show you something in here. So in Linux, if I write ls minus l, sorry, if I write ls minus lc, and it is showing this file details, right? If I simply go for ls, it will show all the files in this folder. Currently I'm in which folder? I'm in this folder. Okay, so if I am doing ls, it is showing the all these file details here. But if I go for ls minus l, it is showing all the file but in more detail. So here date of creation and many other file properties are there. So one of the property, that is the leftmost property, is called permission. If you see here, this is called permission, and if you see, this permission is divided into three part. First part is user, then group, and then other. So there are three parts possible here. So let me explain it with the file, how to open a file. Sorry. Okay, as I said, there are three group: user, then group, then other. Okay, and there are three modes possible. Read means if you give read permission, then one can only read this file. If you give write permission, then one can write also in this file, and if you give x permission, then it can execute this file. So read, write, execute, there are three permission possible. So you can give read, write, x means execute permission to user, group, and other. Read, write, execute, read, write, execute. So here you can, if you see here, for example, particular files, if we go for my file.txt, if I come here, my file.txt, then user can read, write, group can also read, write, and other can only read. Okay, if we go for a.out, then it is saying user can read, write, execute, other a group can also read, write, execute, other can only read and execute, they cannot write. So these are the permission bits set in, and you can also change the permission from here, right? Chmod is a function used in Unix to change the permissions. For example, suppose if I want to change the permission of my file.txt to 777, then I can easily change it. Now it should be sudo. Okay, my file chmod. Okay, so if I go for ls now, so see the file, the you can see here the permission has changed now. Okay, so what is this 777 that I have used? So let that I'll explain it here. So every time there are three bits right here. So read means if I go for 100, then it means it is called read, suppose. Okay, and write is in the middle, right? So 010 will be write. This is 2. Okay, and this is 2. It is right. Right, let better write 444, and then 422, it is right. And then last one is execute, right? So 001 is execute. So this is actually 1, this is execute. Okay, so now if you want to make a combination of all these things, so that you can write now. Suppose you want to give a read and a write permission, so what you'll do, 110. 110 means what? It is 5, right? And what it means, read, write permission. If I want to give all these three, 111, then it is 7, right? And 7 is read, write, execute, and that I have given here, right? If I go up, see, change mode, sudo change mode 777. So 777 for 17 means 17 means for this group, the user, and next 7 is for this, and third 7 is for this. So 777 means each of these user, group, and other I am giving read, write, execute permission. So you can see here rwx, rwx, rwx here, this is a permission. So I think this part is clear. This is easy also, but you should understand the basic concept here, why this numbering is coming. Okay, so now there is a bit vector maintained for all this permission inside for every process. So now suppose if I want to give read and write permission to, so suppose this part is fine. So you have to remember only this. Read is 4 and 2 and 1. So instead of this, if I write here, suppose if I write read or write, this is a bitwise or. So what is read? Read is 100 and write is 010. So if I go for a bitwise or, what will happen? 110. What is this? 110 is actually read write, right? 110 is 5. That is read write. So it means that if you know the basic these three numbers, this the 4, 2 and 1, and if you want to combine them, you can just go for bitwise or. If we go for bitwise or, that is fine. So the same thing is given here. In there is in Unix system, there is a table in this stat.h. You will go for all these properties, all this mask in stat.h. So SIR means, if you ignore, let me means explain you in a simple way so that you can understand. You can ignore the SI part. S underscore, if you ignore this part, then it is read user, write user, execute user, then read group, write group, execute group, then read other, write other, and execute other. I think you can relate this with whatever I've explained using this notepad. Okay. So now, if you want to open something, then suppose if I go for this, let me open a notepad here. Mm. So now if I write something here, like as I said, there are user, then group, then other, and if I write like my mode, if I define a mode like this, mode, let me say has define mode equal to, if I write s underscore I s underscore I user, then if I write uh, r user, then if I go for uh, w sorry, read grp, then what equal to each of these as a number, right? If I, as I have shown here, if we go here, each of these is a number. So 4 to 1, it's for 1. So if you go for this type of bitwise or, then you can create a final bit vector which can represent this complete permission. So here I was showing it for only one combination for user. So if we instead of 3 bit, if you use 3 plus 3 plus 3, you can use for 9 bits, then you can create a bit vector for everything, and that bit vector you are showing here, you can see here. So that bit vector you can create in your program like this. For example, if you go here, if you write only 0 here, that means you are sending a bit vector with all zeros, so you are not setting any permission to that part. So how, whenever you send a f open function, so the what we are discussing is opening a file. So whenever you are writing this type of function, here you will send file name, flags you have already explained. So here in mode, whatever mode you have given, how this mode works. So whenever you write a mode here, let me write it here. So every time, if this is your mode that you are passing here, then how this mode will work. So there is a function called there is a thing called umask for every processor. So there will be already a umask there. You can set this umask also, but actually whatever mode you pass, there will be mode, and there will be a n bitwise n and complement of umask. That will be performed every time when you call for a open function, file open function. Whenever whatever mode you'll give, that file will be, if the file will be, if it is need to create a file, then the file will be created, and permission will be given as that this permission that you are supplying here, and there will be umask already there. And then what it will do, it will perform a AND operation with the complement of umask, and then it will give the permission. So it means that if umask has already some permission written in umask, then that permission you cannot give according to mode. That I will explain here now. Okay. But this umask can also change, means if you go for umask function, then you can change the umask also using this function. That it is I think it is written here. Suppose if I go for this is the mode. This is a macro. So some of the mode written here: read for user, write for user, and read for group, write for group, read for other, write for other. So basically, this mode is saying read and write for all three groups: user, other, and group. Okay, but there is a umask also. Umask is saying write group and write other. And so what I'll say here, so before opening a file, if I write this code like this, as I said, umask can be used to set the umask property. And what I say that there is every process there is a umask bit vector. So and you can set that umask bit vector using this umask function. So before calling the file, if you go for umask function, then what it will do, it will set the umask. And what it will set as a umask, umask will be set like for these two bits. Okay, write group and write other will be set in umask. And then you are going for opening a file here. If this is the file name, you are creating a file. This you are saying this is your mode. Sorry, this is your flag, or the way you want to open a file. This is written here. This is the flag. Okay, so what the way I want to create the file is, I want to create it, and if there is truncate and write only mode, and this is the mode. So mode, I'm supplying this mode. So this, as I have said, whatever mode I'll supply, it will be performed in logical bitwise and with the complement of umask. So what is the complement of there is a, so umask is a 9 bit vector, right? 9 bit vector. 9 bit is required, 3 for user, 3 for group, sorry, and 3 for other. So out of this 9 bits, which are the bits will be, all bits will be 0 0 0 here. In I'm saying about this umask, means what is the current status of umask. Current status of umask is 0 0 0, or everything is 0 0 here. Then next is 0 1 0, right? Right is 1 here, and 0 1 0. This is the current status of umask. So and what you are sending here, you are sending this one to open this file here. So what is the status of your status is say 1 1 0, read write for everyone, right? 1 1 0 1 1 0. You want to give this permission when you are creating a file here using open. But this will be end with which one? This will be logical end with which one? This will be logical and with complement of this. Complement of this means these two, one will be 0 and remaining thing will be 1. So 1 1 1 1 0 1. Then sorry, there should be, let me give a space, 1 0 1. And if we go for now logical end, what will happen? This will be 1 1 0, then 1 0 0, then 1 0 0. This is what it will happen, right? So what is doing here, that though you want to give, this is your one, right? This is the mode that you want to give. This is this the def mode. So df mode is this that you are passing as a file name here also. So what you want to give is read write permission to everyone, all this group: user, group, and other. In all these three group you want to give read write permission, but there is a mask already there, you mask. So you mask is it is written as that's no, you cannot give permission to this write permission to group and other. So there is one. So the permission that you are giving, it will be complemented, and ultimate permission will be given to this. So it means that whatever written in, already written in umask, you cannot give this permission, because of this operation. See, now what is happening, though you want to give read write permission to everyone, but what happens ultimately is read write permission is given to only user, and other one like group and other, these two only get read permission, not write permission, because of this umask. So you have to set your umask, you have to set your mode according to your requirement. So let me run a code to show you this. Uh, if I let me close this one. Okay, file txt. If I open this file, okay, so see there is a mode written here. So mask is 0 initially here. So there is a purpose that I'll explain why mask is 0 here. And here I am trying to open a file, my file new.txt. Okay, let me delete this file now. Here there is I okay, the file is not here. That's fine. That's fine. Okay, and what I am doing here, first of all, I'll open this file. What I will do with this file is not important now. Only thing that I'm discussing here now, how to open a file. Sorry. So how I'm opening it? I'm opening it in write only mode and with combining with ocreate. Ocreate means I want to write something in this file, and if this file is not there, you have to create it separately. First we have create an empty file. Okay. So now, and here I'm passing 0. So let me run this code, gcc, and then the file name is create unix example 2. Okay, let me run this code. So I have run this code. So and then there is nothing to print here. There is no printf. Printf is only for error. So everything is printed. I think it is written something to a file. So now the whatever what it has written in the file is not important. Important thing is permission. So let me run ls minus l here and check this file name. My file new. So my file new, it should be here. Uh, is my file new txt? It is not here. It should, I see it is here, my file new txt. So you can see the permission. There is no permission here. Why no permission? Because umask is 0, umask is 0, and you have sent 0 again. So umask 0 and 0, so there is no permission possible. So now instead of this, if I send, this definition, define uh, mode, if I send this, then what will happen? Let me run this code again, compile, then run it again. Okay, fail to open. Let me delete this file, I think. Yes, because there is no permission. So there was a permission issue because I've created a file without any permission. So that's why it is creating a problem. Okay, now deleted the file. Let me run again. See, now this time there is no error. Clear. Now if I go for ls minus l and go for this my file new.txt and see the permission is according to what we have set here, or what permission we have set: read write for you, read write execute for user, and then I think execute for other two groups. And if you go here, see, read write execute for user, and for other two group only execute permission is there. This is how you can create a mode. Now here if I write mask equal to this two, if I write mask space this two, then what will happen? Though I want to give permission to execute and execute to this two group, but because of this mask it won't happen. So let me do it again. I think we need to compile this program again. Okay, run it again. Now let me check. Now check the permission is now read write execute, then execute to these two. Now execute permission should be removed from the remaining two groups, last two group, I think. My file new, if I go for my file new, sorry, execute is still there. Okay, uh, let me check. Okay, so what happened here? There was a file myfile.txt already there with some permission, and if you go for this code of opening, sorry, then what it is doing? O create means if there is not a file, then it will create an empty file. So if there is already a file, it will not create a new file. So the permission, it is not changing. So now what I will do before running this code, let me delete this code from here. Sorry, delete this file from here. If I delete this file and then I run this code, uh, okay, file is already compiled, so I'll just run it. Okay, I have run this code. Now check ls minus l. If I go for ls minus l, then my file only read write execute permission to user, and this no permission is given to two other groups, that is group another. Why? Because of this mask. So what I'm expecting from your side is you try to write some code based on this you mask and all, then only it will clear. Otherwise, if you just read this book, maybe it is not possible to understand by just reading it. So I have shown you one example. We have to read some file, and then you will understand it how to for this mode and these flags. For these two, you have to understand it by yourself. Okay. So what I have done till now today is I have explained you only how to open a file or the system call actually. So in C, what we normally do, we just go for f open, but actually internally f open also go for this function open file. Okay, here you have to give file name, flags, what is called flags I have already explained, mode I have already explained to you today. And the most important part is what this function is returning. It's returned the descriptor. If it is okay, means it can successfully open this file, and if there is an error, it will return -1. Okay, so file open is clear. I'm moving next. Next is how to read and write from a file. Okay. So you can see there is a function written here. Okay, from now onwards you have to remember that there is a header file. You can use this csf.h. What this csf.h is, this is a header file written in this book. You can download it from the website of this book, or it is, I think it is available with the code that I have shared with you. If you go to this particular code, here you will find this csf.h. So if you open csf.h, all this header file required is already included in this. So instead of remember adding the header file separately, like system.h, unistd, stdio.h, it's and if you want to write a quick code, then what you can do, you can just copy paste these two file in your folder where you are writing your code, and then you can continue with your own code. Okay, so this is a better way. And in this book, all the examples they followed this, so they have just included csf.h. So what you can assume, that if you want to run this particular program, so in folder where you are running this, in that folder this csf.h and csf.c should be there. And these two file you can download from the website of this textbook, or maybe it is already shared with the code that I've shared at the beginning. There also, from there also you can download it. So this line number one means all the necessary header files are already there. And then you can see this code. There are two integer function here, integer variable here, fd1, fd2. These are for file descriptor. So here it's opening one file 4.txt in read-only mode, and permission, not any permission is there. So this file will be open, and file descriptor will be stored here, and here they are closing it. So they are opening a file, they are closing a file, and there they are opening another file, and they are closing so second file is not closed yet. Okay, so you have to remember that every time if you are opening a file, then you have to close. So I don't know why they have not closed, because if they are closing it here, the program, then automatically this file will be closed. But otherwise, it's a good programming practice to close every file. Okay, so opening part is done. Then next we'll discuss how to read and write from a file. So if we go back to my this old code here, sorry, let me open from this tab. If I go for this f open, that or you can say the concept of C programming. Sorry, I think open. Then normally we go for this type of functions, like f get s, f get c. So these two are most important. Then also we go for f scanf. So I think it's not required to explain you the purpose of f get s, f get c, and f scanf. All these three functions we use to read something from a file, or you can say read something from a particular file pointer. So if you remember it properly, that if you are using here f get s, and instead of file pointer here, if you write here std in, then what this means, f get s and get s will be same. So I hope you know the difference between f get s and get s. If you don't remember, you can just search it now. Difference between f get s and get s: f get s is to read a line from a particular file, and get s is read a line from the standard input output. So the standard input, that is from the terminal. Okay, so But at the beginning of this lecture I told you that terminal is also a file, and file that there is a file number already assigned to this input file. Okay. So instead of this, if you write standard input here std in, then it means that f gets and getters will be same thing. But what I am showing here is that when we write a file handling program in C, we have some upper level functions like fgetS, fscanf, and getS means fputs, put C function to read data from the file. But when you go for system level thing, the internal all these functions internally call these functions read and write. Okay, I have only show you some higher level function for read. Similarly, there are upper level functions for write also, like fputs, put c, then fprintf. All these things are there, right? So these upper level functions that we use from C, actually internally they also call this two function read and write. Read is for reading something from the file, and write is to write something from the file. Again, the most important part that you remember from here, what these functions are returning. Okay, first of all, the parameters, what parameters you are passing. If it is a read function, because why I'm explaining all these things, because I'll not write any specific program for showing all these things to you. You have to write your own program, you have to practice it by yourself. That's why I'm explaining each function in detail here. So first let's look at the parameters. First parameter you are giving to read is function descriptor, file descriptor, sorry. From where you will get the file descriptor, you have to open a file before going to read it, right? So if your open function is successful, then what open function will return to you? A file descriptor. That file descriptor you have to pass here, and then you are giving a buffer. This buffer means before going there, let's discuss this size t. So you want to read n bytes. If you want, you need n bytes from this particular file. Which file? The file. Now you will define, like you will point to this function file descriptor. You no need to mention the file name again. After successfully opening a file, you no need to do anything with the file name, only file descriptor is enough. So from which file? This file. Okay, you from this file you want to read n bytes, and where you want to store those n bytes after reading it? You want to store it here in this buffer. So I hope this three parameter is clear. You want to read n bytes from file. Which file? This file. And where you want to store after reading it? You want to store it here in this buffer. Okay, that's why you can see buffer is a call by reference, not a call by value. Okay, and if what this is returning, it will return number of bytes read. If okay, so if everything is fine, it will return how many number of bytes it is read. So maybe you'll ask, sir, we are already giving instruction that read n, so why it is returning how many? We know that it will read n. That's not true every time. First thing is that will not true, because maybe if you want to read 50 characters, but the file has only 10 characters, so end of file function, end of file will reach before reading the end character. So in that case, if there is an end of file, it will return 0. Okay, and if there is any other error, then it will return -1. And if everything is successful and it is successfully read the n bytes, then it will read at the same n here. So basically, when it can read something, no matter maybe it is less than n, but if you want to read 50 but it has successfully read 10, then it will return 10. Okay, and it's maybe possible also that sometime there is no end of file, but still it is not possible to read the complete n bytes that you have sent. So to understand this, I think this point will be cleared in next lecture, in next chapter, when we'll discuss network programming. But quickly I'll explain it. I think this part is written also in this book. I have skipped. There are three types of file possible. What is called normal file, another is called directory, and then next is the network file, or let's say socket file, that we'll discuss in next chapter. So in socket file, it may be possible that the every data that you want to read from this file is not available now, but it will be available after some time. So in that particular, in these cases, maybe if you want to read 50 bytes from that file, but at present you can only read 10, so it will just return 10. It will not return the all 50 at a time. So how to handle all these things will be discussed in this chapter only. But you have to remember, maybe you will ask that I have a file already, so that in that file 50 bytes are already there. So if I go for 50, then it will read at a time. So why you are saying that it may read less? Because this is only true for the means network files, means socket files. So the program that I will discuss here is very important for next chapter also. all these functions that we'll discuss here, you have to understand, you have to practice it if you want to write any program which is written in next chapter, which is in network programming, sorry. Okay, right, almost same as read. You want to write n bytes to this file, and from where the n bytes is, yeah, now these n bytes are written in this buffer. So from this buffer, n bytes you want to write in this file, and what it is written, number of bytes written. If everything is okay, then how many number of bytes it can write, it successfully can read, it will be returned here, and if there is any error, then it will return -1. So there is no chance of returning end of file during the write case. So that's why I think that what I mentioned, that you have to remember that which thing this each of these function is returning. In case of read, three types of return is possible: either number of bytes if everything is okay, 0 in end of file condition, minus in case of error. In case of writes, only it will return the number of bytes written, or it will return -1 in case of error. Okay, read write is fine. The interesting is this. Can you guess this function, what this function is, or what this program is doing? Line number one is including all the necessary header files. So that part I've already explained. Now start with the line number three. Line number five is character C, that is a variable. Line number seven is saying while, and then try to understand the read function. Read. So you can see there is a capital R here. So ignore this capital R. Just try to means read it as a small r. So if it is small r, then it is same as the read function. Just I have explained you, right? That is a read function. So that read, you can see the first is a, what is this first one? First one should be a file descriptor, right? According to read. So do you think it's a file descriptor? And if it's a file descriptor, which file it is pointing? stdin. stdin means it's already, I have said, this is the file descriptor number 0, 0, 1, input, output, and error. These are the three files. They are also file descriptor. So if instead of any new file, or means a user defined file, here it is using stdin file number. So what it will do? So what it is trying to do, it is this read file will read one character, one byte, right? One byte at a time. So it will read one byte from this file, and it will store it in this variable. See, that was the same thing as I was explaining here, right? In read means this will read n byte from this file and store it here. So the same thing is doing by this. This will read one byte from this file and store it here. So what actually it is doing? This line is actually doing a get character, almost equivalent to a get character function, or you can say get C function from C. What a get C function do? If you write a get C, then it is wait for one character that you need to type in terminal. The same thing, exact same thing is doing here. Read std in means it will wait to type one character in this terminal. The moment you press one character, it will read this character and store it in C. Okay, and if it is not equal to 0, when so if that is, it is not an end of file condition, then it will just print it here. Where it will print, sorry, again I said ignore this capital W, just go for write. So it is writing in which file descriptor? Std out is, again it is printing. So this line number 8 is actually working as a put C command. What the put C command is, or you can say printf, also printf %c. If you want to print something using printf or put, if you want to print something put C, both are same. So I'm saying it is working as a put C command. It means that printing this character in this file, std file. This which file this is? This is again the terminal or output file. So I'm not running this code. If you want to run, you can run it. It will be very interesting to see how it is working. So my main idea here is to explain you how to open a file, what is file descriptor, and then with this file descriptor how to read and write from a file. I hope this part is clear to you. Okay, so next what I'll do is these read and write that I've explained, these are the system calls, right? So there are some limitations. I'm not saying there are some disadvantages, there is no disadvantage, but there are some limitations. The first limitation here, you can check the, if it is, as I said, if it is socket file, suppose that if it is a network file and the data are coming from in this file, all data are not available at a time. So data are coming from remote network place, one by one data will come to that particular file, and you want to read it from that file. So initially when we want to read from that file, and suppose you want to read 50 characters, sorry, 50 bytes, but at present 50 bytes are not available there. So what this read will do, whatever data is available, it will read, and then it will also return the, suppose only 25 data are there, so it will return, read 25, and it will return 25 also. So you have to understand that, okay, only 25 data are received, so I want to call it again, I want to call it again for next 25. So you have to handle everything manually, right? First of all, you'll read, you'll go for read, and then 50 here, and then you have to check what is the size. If the size is 30, then you have to again call read, but at that time you have to mention size as 20 because 30 already received. So all this bookkeeping thing you have to do by yourself if you are going for this type of system command, system call by yourself. Same thing is for write also. Means if you want to write something, the entire thing is not written at a time, then you have to maintain a bookkeeping, and you have to call for write again to write the remaining parts and all. So there are some limitations with this system calls read and write, and these limitations are written here, that how this limitations. So it's not like that these are errors. Means if it will based on the return statement, based on the return values of this read write, you can handle it. You have to write your own logic to handle all this, overcome this limitation. But if there is someone who has already written or already handled all this limitation and have given him some adapter function. Adapter function means they will, for example, you can say f scanf, sorry, f open, in C. You can also consider them as adapter function. Why? Because they are calling the system call, system call inside that their from their body, and they are handling all this thing, and finally we are just getting f open or f gates, right? The same thing here. What we will do, if we since we need to follow this textbook, so for the authors of this textbook has written a package. It's called robust input output, and that is called rio. So maybe you will ask question that, sir, why you will go for their input output package? Maybe we can write our own input output adapter functions. That is fine. But why it is easy if we go for Rio package? Because most of the code that is written in this chapter as well as in upcoming chapters, they are using this input output package, that is robust input output package Rio. So it's better to use them. But always remember one thing, that this Rio package that I will discuss from here, and maybe I'll use this term from here to all these remaining lectures of this course. Without all these things, you can also write program using just the system call, that is read, write, and f open. You no need to go for all these things. These are just to make the programmer's life simple. Means most of the thing, most of the logic are already there. You just need to use it. Okay, I just need to call the functions, and all the internal problems are already handled there. So as I said, the limitations that are in original read and write files, that are handled in Rio packages. So in Rio package there are actually four functions. The first two functions are unbuffered read write, and then next two functions are buffer read write. So next I'll explain all this as 10.4 here. So I think the first part I should stop here. The second part of this chapter will start from 10.4, and I'll discuss what is the robust reading writing function as defined in Rio package.